I am Anil Kumar. Welcome to my series on Understanding Cyclic Quadrilaterals Better. We have 4 examples here. The first question is right before you. As we solve these questions, you will understand better how to work with cyclic quadrilaterals. So in our example number 1, we have ABCD is a cyclic quadrilateral. Find the degrees measure of the angle x and y. So ABCD is a cyclic quadrilateral since the 4 vertices of the quadrilateral are on the circumference of a circle. We need to find measure of these 2 angles. We are given a few other angles here. So what we are given here is that the angle here is 30 degrees, this one is 25 degrees, and this one is 50 degrees. Now we'll understand few properties as we move along. In the cyclic quadrilateral, sum of the opposite angles is 180 degrees. Now let's try to see. If we are given this as 25 degrees, this angle of 25 degrees is right opposite to the chord AB, right? So do you see this chord here? So this angle of 25 degrees with point A and B. Now that really means on the same chord, let's find some other angle which is subtended by the same chord. So this angle here is against the same chord, and that has to be equal to this 25 degrees. Do you understand? So these 2 angles are equal. Therefore, we can write that this angle here is 25 degrees. So what we get here is that the angle ACB is equal to 25 degrees, and the reason is that it is equal to the measure of the arc AB, right? So because angle ADB is equal to 25 degrees, right? So both are on the same chord. So this property holds good whenever we are also considering congruent chords. If we say that 2 are congruent, even then this property holds good, right? So from this, the same chord AB will subtend the same angle, and therefore these 2 angles are equal, correct? Now, using the same property, you could also see here that this angle 30 degrees is on the chord CB. Correct? Now if you see the CB chord, then angle Y should be same as 30. Do you see that? And so we can use the same property to write Y as 30 degrees also. So we know now that angle BDC should be equal to angle CAB, and that should be equal to 30 degrees. They are on the same chord, which is BC, right? Sometimes we say the arc, right? So they have the same measure of arc. So we can also say same measure of arc BC, right? We could also write measure of arc. But either way, you should understand that these 2 angles will be exactly same. Got it? So we got our angles, Y at least. So we now know that Y is equal to 30 degrees. To find X, we'll use the properties of cyclic quadrilateral, that the sum of angle D plus sum of angle B should be equal to 180 degrees, right? That is the property which we are going to use, but before that, I notice that this angle is also not known, so we have to figure this out. Okay, So now we'll consider the angle right in the center. Since that is a triangle, let's call this point as O, right? We can actually find from this angle also. So there's an alternate way. So we'll go with angle A and C being sum of angle A and C being 180, right? So we'll get to this step. There are a couple of ways to do the same thing. Let's go with angle A plus angle C should be equal to 180 degrees. That is the property of cyclic quadrilaterals, right? So let's say this angle is Z for us, right? We don't know this. Let's say this is Z for us. In that case, the angle Z plus 30, and here we have plus 50 plus 25 should be equal to 180 degrees. So angle Z is equal to 180 degrees minus sum of all this, so which becomes 5 and 7 and 3, 10, 105 degrees, correct? So that gives us 180 minus this as 75 degrees. So angle Z here will be 75 degrees. Now angle Z is on the arc DC. So angle Z is actually facing the arc DC. And therefore, it should be equal to X. Correct? So we can say that angle X is equal to angle Z, and which is equal to 75 degrees, since both are on same chord. I prefer to write chord. You can say or arc. Or arc. So arc will be obviously DC, and chord is also DC, right? So you could do either one reasoning. Is it clear to you? So using this method of really working out on which chord and which angle, we can actually solve these questions very easily, right? Well, there was definitely an alternate way. I could have found the angle of the triangle, right? So I could have found what this angle is, right? Now this angle here, let's say angle O, so we could have said that angle D, let me get this. So angle DOC will be equal to 180 minus 30 minus 50, which is 100, right? Now if this is 100, in that case, this is 100, not a 90 degrees. In that case, this is 80, correct? Now if that is 80, then X will be equal to 180 minus 25 minus 80. And that also gives you 75 degrees. Is that clear to you? So you could have gone by finding the third angle in this triangle, and that is a supplementary angle. So that gives you 180 minus 100, which is 80 degrees. And then working out the other small triangle OBC, you can find the value of X. So I hope that is clear. So you could do, I can call this as an alternate method. But I'll go with this. Correct? So, because we are going to use this property to solve other related questions, it becomes much, much easier. So now let's take the second question here. So let's call this as our question number 2. We are saying PQRS is a cyclic quadrilateral where PS is equal to QR. They are same chords. The angle SPQ is 60 degrees and angle PQR is 90 degrees. We need to find the angle X, right? So first property of cyclic quadrilaterals, we know that the angle PSR plus angle PQR should be equal to 180 degrees. This is the property of cyclic quadrilaterals. So from here we get the angle PSR equals to 180 degrees minus 92 degrees, since we know that angle Q equals to 92, right? So this is, when you take away, you get 8, and then from 17, if you take away, 88 degrees, right? So what you get here is 88 degrees for this angle. All right. Now, we know these two angles. Since these two chords are equal, we know one thing, that this angle here, this chord and this chord are equal, right? These two are equal chords. Therefore, this angle X and this angle will also be equal, because they are against congruent chords. You get the idea, right? They are against the congruent chords. So therefore, this angle is also X. Correct? Now, we can find this angle X as sum of three angles is 180. So angle PRS is equal to 180 degrees minus 88 degrees minus 60 degrees. That gives you the angle PRS, and that should be equal to that X also, right? So let's figure this out. So when you take away, that is to say 180 degrees minus, 8, and 6 and 8 is 40, 148. So that is equal to 2, and then you take away from 7, 32 degrees. So this angle here is 32 degrees. And using this property of angle against the same chords, X is also 32 degrees. Do you see that? Now, angle P, I should write QPR, which is X, right, is equal to angle PRS, which should be equal to 32 degrees, as they are against opposite, equal, or congruent chords. Does make sense? We are given that PS is congruent to QR. So those are congruent chords, and therefore they are equal. Perfect. Now, since most of the students are not using this property, they really find such questions very difficult. And that's the whole idea why I'm focusing on this in this particular video, right? Now let's take the next question. Let's call this as our question number 3. Here we are given PQRS is a cyclic quadrilateral. PQ is parallel to SR. Okay, so these two are parallel sides. Angle PRQ is 10 degrees. Find the angle PSR. Okay, so we need to find this angle. Okay, now since we are given parallel sides, we can always look into the Z pattern, right? So Z patterns help us to find the angle. So if you see the Z pattern, we get that this angle here is equal to that side, right? Interior opposite angles, correct? So these are two parallel sides, that is the transverse, and therefore this angle should be equal to 10 degrees. Well, the scale is not quite correct, but so we have alternate angles. So we have angle SPR equals to angle PRQ, which is equal to 10 degrees, since they are alternate interior angles. Correct? Now, the sum of opposite angles are 180 degrees, correct? And since these are equal, these two will be what? These two are also equal, right? So let's write this as y and this also as y, correct? So from here, we get that angle y, we can write we can write angle P plus angle R should be equal to 180 degrees. This is cyclic quadrilateral. Correct? So what we have here is 10 plus y plus 10 plus y is equals to 180 degrees. So 2y equals to 180 minus 20, which is 160 degrees. So y is equal to 160 by 2, which is 80 degrees. Correct? So we get this angle as 80 degrees. Now from the triangle, we can find the angle x, right? So now if I consider the triangle PSR, so in this triangle, x is equals to 180 minus 10 minus 80, right? So 180 minus 90 is 90 degrees. So we get this angle as 90 degrees. So definitely, it is not to the correct scale, but that is how we could find this angle. So I hope it is absolutely clear. Now, based on this knowledge, I think you should be in a position to answer this question. So that is our question number 4. ABCD is a cyclic quadrilateral in the circle with center O. So that is the center point. Angle ABO is 28 degrees. Angle CDO is 60 degrees. And angle BCP is 50 degrees. Okay. So we are given these angles. Correct? Now, find the degree measure of angle X and Y. So we need to find these two angles. Okay. Now we could begin with this straight line, a linear pair, right? So we can say that the angle DCB should be equal to 180 degrees minus 50 degrees. So that gives us 130 degrees, right? So we get this as 130 degrees. Now, we can go to this angle. Sum of these two should be how much? 180, right? So angle A should be equal to 180 degrees minus 130 degrees. Why? Cyclic quadrilateral. Opposite angles sum equals to 180 degrees. Correct? So we get this angle A as equal to 50 degrees. Right? Now if that is 50 degrees, then the angle at the center is twice, right? So this angle here should be 100 degrees. So now we get that the angle DOB should be twice the angle A. That means it is twice 50, and that is 100 degrees. Perfect. So we find that as 100 degrees. And now we can easily find x and y, correct? So we have quadrilaterals. So in these quadrilaterals, sum of sides angles will be 360, so we can find x, correct? And here also we can find y, right? We can find it either way. So first let's find x. So x is equal to 360 degrees minus sum of these, which is minus 100, minus 130, minus 60 degrees, correct? So that gives us angle x, right? This is sum of angles. So that is how much? So 360 minus 160 is 200, and from 200 this much 70 degrees. So we get x as 70 degrees. Perfect. Now since x is 70 and we are talking about a cyclic quadrilateral, so that means y plus 60 plus 70 plus 28 should be equal to how much? Well, all this should be equal to 180 degrees, right? So from here we can find what y is. So y is 180 minus sum of these, which is 8, and this is 6 and 7 is 13, 14, 15, right? Which is, so when you take away 2, 7 take away this is 2, 22 degrees. So we get y as 22 degrees. Correct? So from here we get y as 22 degrees. Now we can actually check our result, right? How can we check our result? Well, here's the check. We know this as 100, so that should be how much? Well, total is 360, so that has to be 260, right? So in this particular quadrilateral, which is definitely not a cyclic quadrilateral, but the sum should be 360, right? So here, let's try to add all the angles. What do we get? So the check here is, if I add 260 plus 28 plus 22 plus 50, do I get 360? If I get, then it is correct, right? So 28 plus 22, 30 and 20, 50, 50 and 50 is 100, 100 and 260 is 360. So it works. Do you see that? So that is correct. And therefore, the answer is absolutely correct. I hope that makes sense. So feel free to write a comment, share your views, and if you like and subscribe to my videos, that would be great. And don't forget that the angles which are facing the same chord or congruent chords are always equal, and that helps to solve questions based on cyclic quadrilaterals. I hope it makes sense. Thanks for your time and all the best.